let's just move on. So there's a new name, an official new name. So it was Lunar Prospector, but everyone hated calling it LIP. So we got in just in the nick of time, and the team renamed it or suggested certain renames, and headquarters accepted a Resource Prospector. So that's the new name of this mission that I'm going to talk to you about. Jerry's set up the stage as well as Dale brilliantly, so I can breeze through a number of these topics quickly. Of course, Resource Prospector is about the water, and so you heard about, well, gee, what if you're talking about prospecting, you have to be a little bit more definitive. What are you prospecting for? Resource Prospector has focused itself on prospecting for water. So we know there's a range in forms and distributions and concentrations. So we know that their water or other hydrogen-bearing compounds are there. We've heard about that the last few days. So the big question right now is, but exactly where are they? One of the takeaways that I think we can all agree on from the last couple of days of discussions is it's really complicated. There's a variety of forms of hydrogen-bearing compounds. Some might be migrating exactly their form, distributions, locations, both laterally and with depth. We just don't have enough information on any of this yet. And if you're really interested in using water or any of these hydrogen-bearing compounds as a resource, you need to understand that better. So one of the things we're really interested in doing, and this gets to a question somebody asked, was specifically why would you go to a rover versus some other non-mobility asset, is we are really interested in understanding the heterogeneity at scales that a person would walk, for example. So if you look at the L-cross and the neutron data, and Rick Elphick's presented this a few times, if you try to reconcile those two observations, it suggests something that is patchy or buried under some kind of desiccated layer. So either a desiccated layer of 10, 20, 30 centimeters deep, perhaps, or having patchiness. This is a near-infrared camera image of the Cabeus impact site from L-cross. If you filled in some of these areas with 20 or 40% ice-rich ore, you could, consolidate or reconcile the observations in a number of these data sets, some time dependence, either possible migration or production destruction processes are happening on the orders on the scale of hours to days. So this is really something we need to understand better at these scales of tens to hundreds of meters. And that's what Resource Prospector is really focusing on. So Resource Prospector is a mission to really understand the distribution of the volatiles, namely water, and I actually understand the potential for ISRU. It really is a prospecting and ISRU mission. It first and foremost prospects, looks for the to characterize the distribution and other volatiles, mapping it both laterally as well as with depth, measure some of the bulk properties of the samples collected, understand what volatiles are in the soils, for example, these, and actually provide or measure limits, excuse me, on a variety of isotopes. This is really trying to understand what we have there, potentially where it's come from, so we can extrapolate and understand the process a little bit better for the distribution, retention, and of these volatiles in general. The other half of Resource Prospector is this ISRU demonstration. It's one thing to find it, but we need to start making steps in how do we utilize it, how do we extract it, how do we process it, capture volatiles, for example, how do we produce volatiles from the native material. So Resource Prospector also will have a demonstration in a variety of ways for the initial ISRU steps we want to take. So right now, Resource Prospector is currently a pre-phase A mission concept, and we are building hardware on the payload, the Resolve payload, to buy down risk. And that's been going on for the last couple of years, actually, and you'll hear a little bit more about that. We're gearing towards a concept review, mission concept review in this September, and hopefully after that, moving on to flight. This summarizes a lot of what I just said right here a little bit more clearly. It's a pre-phase A concept with a concept review this September. We are now targeting a launch in May 2018. That's actually just to get all of our various partners schedules in line. It would be a May 2018 as a South Pole landing. It is a Class D Category 3 mission. For any of you NASA junkies, that means something to you. Otherwise, it just means it's low cost and acceptable and has a higher tolerance for risk. So it is more in the lines of Lunar Prospector and L-Cross and the LADI missions in terms of its categorization. It is currently a NASA Canadian Space Agency collaboration, but other international partners and industrial partners may be coming on board. And an important point to keep it inexpensive is it is a solar-powered rover and is carrying the Resolve payload. The Resolve payload has been under development in one form or another for probably 12 or 14 years, Jerry could say exactly. But the latest incarnation of this is being built, engineering units for testing, environmental qualification, et cetera, now. So this payload is quite advanced at this point. We do have signed at headquarters level 1 requirements, and what's interesting about this mission is it's an AES mission. It's coming out of the Advanced Exploration Systems and the Human Exploration Office. And they do robotic missions to advance human exploration, and they tend to have requirements that are, for this Class D type mission, they're a bit lighter than you might expect out of a science mission directorate. We have 2 level 1 requirements. You can see them here. Basically land at a lunar pole and prospect for volatiles. That's the first one. And then the second one is basically obtain knowledge about the lunar surface and subsurface volatiles and materials. Those are kind of vague, very deliberately vague, and they are kind of a catch-all. The project office, flight project office, further defines these into level 2 requirements. So this is a paraphrasing of level 2 requirements rather than throw them out there and put you out of sleep. We have the missions built upon a minimum, a full, and a stretch goal in terms of success. The minimum success is really just as simple as taking measurements in a couple places separated by at least 100 meters. We want subsurface or surface measurements. That's minimum success. Full success, we do both subsurface and subsurface, and we traverse at least 1,000 meters, and we do ISR demonstrations. This is really what the mission gears for. This is what we're building. We have a variety of stretch goals, and this is basically as we see opportunity or as resources, not lunar resources, but monetary resources permit and schedule permits, we try to obtain these variety of stretch goals here. So where do we go? Jerry touched on this already. For this pilot mission is kind of the way I see it. It's one of hopefully several where we are demonstrating the technologies, the ability to do these kinds of missions on the moon and other bodies, airless bodies perhaps. We're looking at a particular location that has a sweet spot, basically, where we have potential for subsurface volatiles or surface volatiles. We can talk to Earth directly. We don't need a comm satellite at the moon, for example, to do this. We have traversable terrain because we do want to traverse. We want to understand distributions across tens to hundreds of meters. And we need daylight illumination. We are not going to have any RTGs or nuclear power sources. We're doing this solar to keep the costs low. And we've found a variety of places where all these things come together into a sweet spot that's been known for a while. Thanks to the LRO data sets, it really makes it possible to identify these places. And Jerry showed some of these figures I'll show in a second here. Right now, though, we have a selection criteria. There's a site selection team that's been stood up for about 8 months now, been working on site selection analysis for this pre-phase A study. We have a flow that we've defined that gets into basically defining a landing area operations or traverse map. and it includes a hydrogen signature, near-surface cryo temperatures, basically cold enough to keep water, sufficient water, etc. I've bugged a number of you all for help with a lot of this. So this is a process that we're defining really in this pre-phase A. If we were to go to flight, we basically have a system or a process in place to follow to select the final site.
Hey,
this gives an example of what copy. This gives an example of some of the data sets we're looking at, both depth to stable water ice and maximum days of sunlight. So the result payload, resource prospector is flying it. It can consists of an auger and coring or sampling drill, a near-infrared spectrometer for surface and auger cutting evaluation, a neutron spectrometer for subsurface hydrogen detection, a oven and volatile analysis system, which basically allows us to take a sample, bake it, and analyze it for whatever volatiles might be in there using a GC-MS system. And of course, it will be on a rover that the Canadian Space Agency is providing. CSA is also providing the drill. So real quickly, this kind of gives you the overview of what Resolve will do. We'll get there. We launch. It's right now looking at a direct flight to the moon. We do a real quick checkout because we only have, those sweet spots are only about a week long. So we get off the rover quick. We begin our surface ops. We do mapping. We find these sweet spots on the surface or areas of interest that we want to examine, and we choose to drill, auger, or core, and then we actually heat those materials, examine them, and also go beyond that by doing some hydrogen reduction experiments to make water from dry regolith. And then basically at the end, we show the water. We'll actually attempt to make a water drop on the moon and take an image of it. This gives a notional traverse for one of our study map areas. This is an area inside of Cabeus we're looking at. Just shows the kinds of scales we're working on. The full mission success will be able to traverse at least a kilometer and go into shadowed areas for temporary operations in shadowed areas, so we can do sampling inside of shadowed areas. Jerry mentioned we demonstrate a lot of this in a field test. We did this in Hawaii where we had buried targets. The science team had no idea where they were, but we were able to identify them, localize them. We did augering. I never knew how fun augering could be. We had a near-infrared spectrometer looking at cuttings and really demonstrated that it's a very quick and easy way to get some good information on subsurface volatile content. It was a really useful test that we did out in the field. So real quick, where we're at again is this phase A study. It's going on for another few months before we have this mission concept review in September. Hopefully, following successful MCR, we'll have a systems requirements review in about 1 year later, with a launch in the spring of 2018 to the South Pole. This mission will make obviously very unique lunar volatile measurements and demonstrate important aspects of ISRU. And really, it's a step in one direction. It's certainly not going to tell us everything we need to know, but it's going to provide the technology development and the techniques for resource prospecting utilization for the moon and a variety of other solar system bodies you can imagine. Thank you.
Thanks, Tony. Very exciting mission. I hope we hold to schedule on this. Really looking forward to this. So we have a couple of questions up there, and then if there's no more, I have one as well. So from Durga Prasad, would it not be good to have impactors such as LCROSS/penetrator missions at a few selected sites as precursors to such resource prospector missions?
Yeah, you heard, I think, on the first day about the possible Herschel impactor, and that's one of the things we were thinking. So absolutely more point measurements with impactors using LRO would be very, very valuable, especially in these areas where we're interested in, where we have this temporary sunlit regions, where you have this crowd temperatures at 10 to 20 centimeters below the surface. We haven't sampled those in any way. It'd be very good to sample those before going. So yes, it's just a matter of time and money.
Thanks. Next question from Pam Clark. Approximately how many drill sites over how long a traverse do you expect to cover during the course of the mission?
So our stretch goal right now, which we think is doable, is at least 8 augers and 4 core samples. So the augers are relatively inexpensive in terms of power and time. So we'll be able to sample material with coarse resolution down to about 30 to 50 centimeters. So that tells us whether or not what the neutron spectrometer is seeing is contained in the top 30 centimeters, or is it actually deeper. That immediately gives us a really good handle on the distribution of volatiles in the soil. If we decide to core, that takes a good 2 hour. That's a 2-hour operation, an hour for analyzing it with a GCMS, and so on. So that's per sample. So we really have to be a lot more judicious with where we core. Right now we're planning at least 8 augers and 4 core extractions, so
Okay.
down to a meter.
Great, great. And another question came in from Michael Poston at Georgia Tech. What is the relative cost of a mission like this versus a dedicated impactor?
Well, LCROSS was a dedicated impactor, but it was on a launch vehicle, so it's a tricky question. It was $79 million total cost, and this mission is a Class D $250 million cap to NASA. That does not include the rover contribution from CSA. So it is absolutely more than a dedicated impactor. But again, LCROSS was a unique situation that we took advantage of the LRO launch vehicle. Launch vehicles are around $100 million a piece nowadays. So that's the trick. If it's getting that, finding that situation again where you either have a spacecraft that is needing decommissioning like Herschel was, or there's an opportunity again to hitch a ride with somebody and take advantage of throw mass to the moon.
Well, and it also gets back to what data are you looking for. Impactors provide certain data but ground truthing it, as Tony has mentioned, provides a whole different data set.
That's right. That's why I emphasize trying to understand the distribution at scales that we just cannot achieve from an impactor mission or even from an orbital mission, at least right now. At these scales of tens to hundreds of meters is something that I think is really important for us to understand the processes that govern the sequestration of volatiles in the lunar regolith at the poles.
Okay, and we're running slightly late, but let me ask this last question from Russell Cox at Fletcher Engineering. Are you still looking at Astrobotic for launch and lander?
There is, the launch right now is, no, it's a NASA purchased launch. There is a request for information for industrial partners to interested in providing a lander that should be coming out shortly.
Okay, great. Well, Tony, thanks again. Really appreciate this, and I think that all of us online are just fantastically excited